Swedish listening. Should I just take it in English anyhow? We should, because we're recording and have it online. They don't have a saying. Yeah, we'll take it in English. Yeah. Okay. Cool. My voice is a bit bad because I have a voice issue since years back. Sorry about that. I'll do my best. And that one, let's change to this one here. Dark mode. That's all we needed. Dark mode. It's like you'll be even more impressed when I say that, like, modular monolith. I have no clue what it is, but we'll define it. I just needed some kind of wording. It's an official word. So like, oh crap, can I make something else up? So let's call it like Marcus modular monolith, but it actually seems to align with the Wikipedia definition. So what's a module? It's kind of like a piece of Lego. You can take it out, replace it with something else. Even the word module is modular in itself. You can replace it with component if you want to. There's fine, thin, different in some cases, but with components, you should also be able to replace it with something similar. So that's what we're going to talk about today. But just remember, this is my style of doing it. It's not like hexagonal architecture or clean code by Uncle Bob and me teaching it. This is my way. And it's one of the most requested things when I go to teams and teach them how to program and organize their codes. Like, do you have any information about this? Like, sorry. I was planning to write a book. That will happen when I'm like 60. What is now 67? We increase it 65, 67. When you go into Swedish pension, and I'm not that old. So who am I? Marcus modular Rådell. I am. I'm really proud that I'm the current head of curriculum at SALT since about 3 weeks back. It's my dream job. So if you have questions about the bootcamp SALT here in Stockholm or in Amsterdam, check us out. Reach out to me on LinkedIn. I heard that we have a QR code up here, there, down there, somewhere. Yes, cool. We're looking for a head instructor for Java and .NET. So if that's interesting, then reach out as well. Now, I'm not going to have a big presentation. I want to live code for, let's say, about 30 minutes or something. We'll see how it goes, how much I talk, how much I code. The main thing is to show the progress, because if I just show some kind of end result, this is what it looks like, I can just be upfront. If you copy that, it will be a shit show. So I'll give you an overview to show you what I'm talking about. This is a demo project called Code Typing. You have a README. So it's called Code Typing. It's meant far in the distant future to be a speed typing practice tool for programmers. So you can create some, like, write this code, and then you give it to someone and they try to write that as efficient as possible. Right now, it's just a CRD in CRUD. So create, read, delete for adding challenges. That's all it is. And that's to keep down the complexity so we can focus on the architecture. So here's the model, which basically means this is what you find in a Postgres database somewhere. I have a UUID as the ID, name of the challenge, the content, and level, pretend it's how hard it is. That's it. If you have this little in your app, you do not want architecture. You just want to put it in production. So this is the starting point, modular monolith, and I'll commit to that. But also, if you go to my GitHub, Marcus Rådell / code typing, look at final modular monolith, you can have that as a reference point. There's minimal amount of code, so you can kind of see the architecture and not get lost in the details. You will anyhow, but this is what the entry point. And those of you that don't know me, you will see a lot of index files. You'll see a lot of relative short words. I don't like repeating myself. Get used to it. It's a good way to program, okay? But if you're not used to it, just know that it will be a frustration. In reality, it's usually not. So we have the entry point main. We create some kind of app, and then we'll listen to the port 3000. Notice this here. If you're coming from object-oriented programming, class-based programming, you would write new app. This is the same. Every time you see factory from now on, think new. It's the factory pattern. And first pattern here, always use named exports. The language we use when program is much more important than we realize. So just make sure that it's not too easy to make, like, rename a default export to something else. Makes more sense as you scale and want to, like, a solid architecture. If you can't speak your code, then you have an issue in communication that will reduce the quality of the architecture, right? That is kind of like the main thing if you want to think about architecture early on. Get the wording set. You don't have to set it right, like it doesn't need to be correct, but you need to make a guess. You need to agree and bet on some kind of wording, set it as a standard throughout the design, throughout the code, then you can change it moving forward. If you don't set it, you can't change it, okay? Of course, we have tests. Everyone have tests. We don't deliver anything without tests because then we have to test it manually, and then we don't program. If you don't write tests, okay, I see some squinting eyes. We have some people that don't write tests, I think. I'm in the same situation. I should also write more tests. I rarely get the chance to because I'm not that comfortable doing TDD and everything you should do. You can still write testable code. But now we have a bunch of integration tests here. Let's see. So we have the app factory source from before. We also have an arrange app, which helps to empty the database. So I won't go through that, just like it makes it fast using integration test. It also means that each test will wipe and then run the test. So you need to run the test in series, not in parallel. That's kind of the definition here, that integration tests use a real database that will cause it to slow down. So here, for example, we see arrange app being used, but it's actually not being used up here. If you use the before each or after each, why? Like, that's a serious question. Like, do all of your tests always, by definition, need the same before each code to run? If so, I won't complain. But if you can't make that guarantee, and none of you will be able to make that guarantee for the foreseeing future, just write something inline. This tells a story. This needs to be arranged. Okay, that's this one. Just make another arrange or setup function that does something different, and your code says what it does. Don't pile it up in the before each. Now, let's go to the problematic part here. We have add a challenge as an integration test. We have some data. We prepared the app. We have some input data that we send as a post. And then we check the result by getting something. And then we want to make the assertion. And then we see here that we do something a bit magic on 48. Deterministic result. This is, you accumulate everything in an object, except level and ID, because those are not deterministic. The ID will be generated and unique each time, and the level I want to go into detail why, but it will change each Monday. Just we needed something to use the system clock. So these are not deterministic, so I can't integration test them. So I need to pluck them away and test whatever is deterministic instead, which you do here. That's an issue. It's fine in the beginning, like carry on, ship stuff, move on, but it is a problem. So scaling up, these integration tests are failing. I think they should work now. Christopher, we talked for too long. Is it the database? Invalid, NKey invocation. It should be the database. NPM, DB. If it doesn't work, then yeah, the demo spook, I'll just carry on. They worked. So each commit, I'll just assume they will work. Sorry about that. Let's see. Okay, so the actual app. We have the app factory, and raise up hands in the room or online if you want to. I want to see you, but participate. Feel good for you. How many know Express and TypeScript? Yeah, that's good enough. Sorry for the rest of you. We basically have very normal code, status endpoint, checking for that the server is up and running. I have a Postman file. So if you go to the production system, for example, you can just download the JSON and import it, and then you have all the endpoints. So it's kind of like self-documenting API, but manually. Then comes the real REST stuff, and I hate Rust, but we also had another session on hexagonal architecture, and I know that most of you will be forced to do REST APIs. I do like just get post. That's good enough for me. So just know that I just slight variation, but this works well with REST. So we can get by ID. We can create a challenge. That's the complex one, if we scan through how large they are. We have deletes. So we should have, yeah, the really short one. Get everything is one big file. There's no problem. And what I will do now is to introduce this like modular architecture. It is valuable. It's valuable to do early on, but usually once you have 2 entities using CRUD or more, 2 or 3. For one, this is only for demo purposes, and I will try to focus on, let's do it with the extremes, get all and create the simplest one, just show concepts and then show a bit of values for create. And we'll see if everything it keeps on breaking, but hey, live coding will adjust. Anytime you want to introduce layering, you need to start in the top layer and break it out, and then you can do more internal stuff. So the top layer now is the controller layer, and then underneath in a traditional app you will have controller. What's after that? Service. Yeah, I have a nod. Repository. What do you call it? Data access. No nods. Yeah, not okay. Data access. Let's go with that. So, but 3 layers, and one's basically the input layer. One is the logic layer. One is the output layer. I'm cheating now, but from a like really distant perspective. So we'll start with the controller, and we want to break out the challenges module. And we want to modularize it. The status and the slash stays put because they're related to the actual application itself and how that works. That would be its own module together with a bunch of express specific code in the future. So let's see. This has been the most hard, simple part. Naming the folder, people always think like, you can't call it modules. Like we have ECMAScript modules. We have Node modules. Like, okay, you know what? We call it the, what have I had? App. Yeah, I've gone with that. There's so many names you can go. Just like, if someone hates it, call it whatever, ABC. You don't have to care, like ship stuff. But for this session, and if you don't have anyone with hard preferences, just call it modules. People will get it. And of course, we have an index file. Great. In here, we do want to re-export stuff. That's the only part that we're doing here. Export star from something that doesn't exist. This is me doing cognitive, low cognitive burden coding. I try to write code that doesn't compile, because then I get red squiggly lines that tells me what to do next. I want someone to tell me what to do, and you're not contributing, so then I have to do what I can do, and I don't have money. I don't have $5 for Copilot, so yeah, this is the best I can do. We're going to have a module called challenges. Yep, and it doesn't exist. So what do? We create challenges. What's the first file we create? Yay! Sensei has taught you well. And when you come back to work tomorrow, everyone will hate you. Okay, so now we actually need to do something here. And the other pattern that you kind of saw a glimpse of is if we have a challenges module, we will probably need to contain it somehow, send in some dependencies, separate stuff. That means const challenges factory. And you will have a person in your team saying that's way too verbose, just uppercase the C, and then you will struggle with naming again. Just adapt, let them decide. As long as you get the right modular code, be happy about it. You'll run into issues with uppercasing because of reasons, but you'll find that out. Okay, so now we actually have something. We can call this constructor function. We can send in stuff like the database for those that already know the 3-layer architecture, and then we can return what we return. So right now, we want to contain that top layer, the routing layer. I will skip a few steps. That clock doesn't work. Oh, I have a clock here, of course. Half an hour. No, did we start 15 past? Yeah, that's good. Yeah, so in that case, we need to be able to create a router for challenges somehow. I will do it this way, and I will go into one soon. Router factory means that I need to create a router in here. And we can do that with router like that, I think. Import from Express. And if we just double check type, yeah, router. That sounds good. So return router. Then formally it's a factory, but we need actual content as well. So let's go back to the app and grab from line 20. Then we have the top one down to the Let me sheet app. Okay, got rid of them. We need to send in Prisma client, Prisma client, add import. Notice the naming. This is the Prisma client. It's not like Prisma or DB. Prisma client with the type Prisma. Try to reduce the number of variation of a name, because naming is, we agree on a name, Prisma client decided for us. We have someone on the team that hates it, change it, move on. But this could be sent in here, but we will see later when we pull out the service layer in future that we need to have Prisma client at the module level. Router factory doesn't really need to be a factory. We don't have any extra dependencies. But if you want to use this module without the router, or maybe you want to use, nobody uses GraphQL, so let's add that. TRPC, something cool, or WebSockets, or CLI, or even I usually do a sandbox.ts and do some manual testing for it using TypeScript. You don't actually want to pull in Express and the whole router setup thing. You just want to be able to use it. So it's good to make this lazy. If you don't know what lazy means, it's basically you need to call a function before you actually use it. That's the only reason right now. And most things are green. We need to import that one. We need to change the name now. Function 2, router. And then everything is green in here. So in that case, and pretend I ran the tests, and they were happy. And I was so proud. Next. There is a recording proving that we got it working. It only failed once at the end. And then it worked again after recording. So now we just need to hook it up. Okay. So const challenges equals challenges factory. Expect one argument, the Prisma client. Okay, so it's happy. And app use. I'll get to the URL soon. We haven't fixed it. Okay, so let's just do slash for now. And say challenges router factory. Now I think the code does what it should. So let's just go in here and make sure that we remove the API shell in this part and put that in the use state outside. So already now we're kind of like separating it a bit. Just know the way I'm doing it, that's a choice. So let me show what I mean with that's a choice. You can let it own its own name, or you can have it on the outside. Depends on which questions you want to have an answer to. Like if you want a router factory to have the name challenges as part of the relative URL on the inside, that's totally fine. It's even more modular in a sense. It's more self-contained at least. But using this style, I get a good overview of the relative URLs. When you have like 5 or 10 of them, you can actually see the relative URLs. You have a good overview where this URL points to this one. That's a nice thing to have an overview of. If you say like, we just assume that we know it based on the actual name of the module, that's also fine. So we'll go in, we'll fix it. Post. If you see me making, you're my test suite now, so if you see me messing up, please let me know. Otherwise, this will be recorded and permanently shameful. Which is fine. Shame is a good driver to improve. Okay, so now everything is refactored. This is a huge commit given how much time I spent on it. If I shut up, it's not that hard, to be honest. So let's go through it. We have the challenges. If you work in a multi-team project, what happened now is that someone can work with the app or another module, and you will not have a merge conflict as long as you stay in your module. If you know that the team works in different modules, any merge conflict is a failure. Oh, that's yeah, okay. Yeah, that's. I guess that's a hot take or something. Is it a hot take? Merge conflicts are valuable and teach you valuable life lessons. And, uh, not really. So it's really good to just realize that the more way to modularize your code, the more distributed your programmers are, the more you can actually modularize the code. I have a folder now called module, but this is actually practical. We won't see it as much in the live code, but I'll show you at the end. It doesn't stop here. You can go to extreme lengths of containerization, like just make it smaller, more isolated. That has a cost, of course, as we can see with the index files and the re-export and everything. Point is, if you do another language, the re-exporting stuff is a bit annoying because since I do export star, this is what we do in TypeScript. I do it in Rust, and I guess in most other languages, we would do export star as something like that. But this is then the same issue as with export default. In some cases, you lose control of the naming, and it's not dangerous to do it this way if you can get the whole team to do it. But this is more the standard way to do it in TypeScript. You think about how it works when you import stuff from React or whatever. You usually don't go React.useEffect. You just import the thing you want right away. So you'll usually have shorter names in other languages. Um, okay, so here we are, and everything is contained. So, but it's not that layered architecture yet. But the good thing is, now it's modular. Now, if you want to have a three-layer separation, or if you want to have like a hexagonal structure, whatever you want to do as an architecture inside of the module, you can do it. And the main thing is you can have multiple architectures in different modules. This kind of way of programming makes sure that the team can do experiments without screwing things up for the rest of the team. You want to rename something internally, go ahead. So now, for example, the team knows I have started to do the challenges factory API. It's ready to use, but they don't know the internal quality. So first now we focus on the external quality, the naming of the API, the URLs, everything that's knows from the outside of the module. That's important. That should be set in stone now, soon. Um, Then once you're done with the external part of the modular architecture, then you can just improve as you need more quality. As we don't need here, but we will need in a more complex product. So let's do the last part here, and that's to have a service. So we want to break out the service here. And then service factory. When I'm demonstrating this, you will see a lot of reoccurring patterns, a lot of similar shapes. Realize that as long as you um, see the same patterns repeating themselves, usually there's a chance to create a lib that does the most things for you and reduce boilerplate. And that's not valuable to show during live code. And it depends on the maturity of the team. So if you introduce it to a new team, add a boilerplate, get people used to your way of doing architecture, make sure that you repeat it during 3 or more modules. If you see the same pattern happening again naturally across multiple modules, across multiple programmers, then you're ready. Then you can actually reduce a lot of boilerplate, but we will not do that here. And I have one repository I'm really proud of. Is that fine? Yep, thank you. And it's a sync, and then for now, I'll just take nitpickers. I know that you don't need a wait in some of these cases. Just know that I don't want to get into that conversation during live coding, so I will try to overuse that to make the example clear. You can optimize the awaits away. Okay, so let's see here. Service factory. We need the Prisma client. Wait, service, get up. And we run the test, and it's green. Okay. By now, you should see that there's a couple of different ways I'm doing it. The router factory, for example, that's inline. The service factory, they correct that, still in the same file. It's pretty dirty, right? And this is not good architecture. But from the outside, it's neat. So we have contained our tech debt. If you create another module, you have an additive tech debt. If you do this without the modular architecture, you have a multiplicatory effect. All the tech debts accumulate together. This is a way of actually containing the tech debt so you can more tech debt without like ripping out your hair as a programmer. So when they say like, can you ship it faster? Yes, you can. But after you ship it, of course, you get it done, no matter what. You add the tests, make them actually green, and you take your time and you make sure that the product owner understands you will not move until you are deciding that you're done enough with the quality according to the team standards, right? That's not up to the product owner. But it's also up to the product owner to say, we want to ship it fast. So do modular monoliths. Okay, so get all. That was the simple case. In the next case, we will have the create. And that will be a bit more complex, if I remember correctly. We have the post. Try. So down here. I think I have one too many at the end. Let's see. I grabbed too much. So yeah, I grabbed. Let's redo that actually. So we do want the rectal body stuff on the outside in the controller. We want to have the validation in which layer? So, okay, service layer, raise your hand. You want the validation in the service layer. You want it in the controller layer. You're fired. Okay, of course. Okay, but seriously, the way you write code in a traditional monolith, yes, you want it in the controller. Then you must use that controller. You can't have a different entry point using WebSockets, or you can't use that, like, see the data using some kind of sandbox mode, which I will show. So in this architecture, that's a no-go, and that will actually be a challenge. If you use some frameworks, they will own the validation in the controlling layer. So be pragmatic and keep it there. Just know that you can move it down a step. And the way I will do it is boilerplating. And to remove that boilerplate, you need them to have that mid layer where you have your own library kind of automating for you. So in your case, if you raise your hand, you want to do it in the service layer, that's more boilerplate. And it might not be worth it for you. Yes, you will not do it, so let's pretend it's worth it. So in our case, we want to move that. And let's see, we want the rest on the outside. And let's cut it out just for me to keep track of it. And that means that here I can't do rest.send. Forgive me, mother, I will use a throw. This is not how I was raised. In the end, this will be a validation error. Let's skip that for now. Here we go. That's faster. And then we need args. You can take them as 2 arguments, but then it's harder to boilerplate. So I will just show you like the step before. And string. And we say that it's a string and then we validate it. If you use it through the sandbox, I haven't shown or explained, but if you then you can actually know that it's having a string. If you do correct body, it's typed as any type, and then you will actually know that you have 2 strings. So we need to validate anyhow. So yeah, that's what you just know. And to get it working, we then need the structure, name, and put. Okay. And we should have return ID. Again, it's to conform to that service method. If we return it as an object, we know that it's only one object that we return. If you don't care about that, you can straight away. Let's see here. REST JSON service dot great. And now we do rec dot body. remove that. Uh, Factory. A good place to put it would be a file named service. We'll grab that one. Put it, export, fix the import, service factory, Prisma client added. Okay, so it's green. And then we need to import it. Import the service factory from that file. Works the same way. Remove that imports. Starting to get cleaner. So let's make it refactor. Notice the tiny commits. Make sure that you do that one thing at a time. Take small steps. Now I want to do the same with the Rådell factory. You might have done it earlier. Doesn't really matter. Now, is it here? Should one too much. Let me. Okay, I'll just. Is it the highlight? No, this one. Router factory, but we still need that. Okay, yeah. We'll see why. So router factory will depend on. So here again with the naming, I'm not really satisfied here. This is compromise. Internally, it uses the same name, but it uses different arguments. Basically, partial application. So I won't go into details, but just know that you could say like router factory with service or whatever, just to separate naming a bit. But even when I try to specify a better name, people still get confused. So yeah, we'll just use the same name. Export, and we actually need to export our factory equals, and we need the service. And then I need a type, and that will be an external type because we will be able to use the service from outside, which I will show. So in that case, challenges service. If it was only internal, I would just call it service. Oh, yeah, I'll change that later on to match. Breaking my own rules. Okay, there we go. And we need the Prisma client. We need the Prisma client temporarily. So let's say I broke everything out. That means we would have ID. Let's remove that one. Delete. Let's remove that one. Just to save focus, because these are as I said, get all and the create. That's what we will focus on. And while you break things apart, yes, temporarily just add the client as a second argument. Remove it when you're done, because that is not distinct outside the partial application. And apologize if you don't follow the virtual application. It's just a function returning a function in our case. So now we need to fix that type. And let's do it here. Export service. And that is not service factory, that's the type. The service factory returns a service. That's what you need typed. Think back to OOP, class-based development, and like send stuff into the constructor that gives back the instance itself. And what we do here, we do it like this. Done. Yeah. Oh, that was good. Thank you. Yeah. Don't start. Let's just stop here. Again, someone will hate this. If they do, you will have bigger problems. So in this case, you can just type it manually and like, hey, no, you don't hate it anymore. Then you start to validate the way we should do it using something like SOD. And then you will still write this kind of code. And there's a reason why return type is part of the standard TypeScript. So don't be afraid of it. And all it's doing is saying like search factory, that const, I want the type of it, but I only want the return value. So just inferring the return type. And if you think it's scary and you don't trust it, whatever, write it manually, whatever that gives you. Have fun the product going. Just hold on. 15 more minutes. I need types. And also check out Theo, if you know him on YouTube. He has a lesson about return values. Trust the return values. You haven't learned TypeScript yet, especially not for objects. All right, let's carry on. And so this one export challenges service. Remember what I said, like in the index file here, we now return service. So it's external. So remind me, is it like that? If you just want to type? Nobody knows. Okay, let's, for now, from, so don't mess up. Service, and now they have access to too much. So at least they have the type. Actually, you can do like that, but you wouldn't. You would have a types file somewhere else. So let's not confuse. Let's just say they can do it if they need to. If you need to improve it, it's linked in the end, and I'll show you the real way how to do it. Router factory. Okay. Looks right. Challenges service. Is this a good import? What are you allowed to import? What decides if you're allowed to import something, or like, you shouldn't? That's a good thing. Like, is it cyclical or not? But let's say. Let's do this. Ah. Is this good?
No.
Okay, good. But this is, oh, sorry, one too many. But this is fine from this path. Okay, so the golden rule, don't have, you can have as many dots, slashes as you want to, but then just one folder. Then you need a bunch of index files to make that align. But then you get that same feeling as most other third-party libraries. Some of them, due to tree shaking, they actually do a bit of cheating. You're allowed to have like 2 or even 3 folders deep, but they really want to keep you on the first folder by convention. But you can drill into node modules, QS, whatever, if you want to. Nobody is forcing you to stay out of it, except the fact that everything will crash and burn sooner or later. So same thing with your code. Don't do less quality than them. So in this case, yes, you're allowed. But you're not allowed to import a service file from outside. You need to go through modules. So anything here, you're actually allowed. And we already have the only thing that's allowed to import. Put that, no matter what architecture you use, please follow that. Like short import paths and long re-export index chains. That will make sure that you can refactor your code a lot more in isolation without affecting the outside. So now I can rename service and it will just affect the inside of the module. Let's see in time. Yeah, we're kind of doing good. I will soon jump over to the pre-cooked one and see if I can show some. Oh, I have working unit tests, but then you will see the failing integration test again. Crap. Okay. So let's see here. We have broken out those 2. Everything is good. But what I haven't done here, we still rely on the, okay, so one more thing with TypeScript magic to see live. The traditional architecture with 3 layers and how you do it, then you're actually not allowed to depend on outside interface. Interfaces in like sharp, whatever, that doesn't apply. But yeah, there's no better way, but even if it's a type, it's an interface here. So we're not allowed to use Prisma as a type in here in the service factory. So we need to spend our precious time replacing all the functions that we want to use in Prisma, like snooze. No, we don't want to do that. So let's do the TypeScript type sprinkle again here. And let's just pretend have our own DB interface, but it works the same way. Now I just need to hire someone to type it out because I don't want to. Or we can do export type DB equals. Do we have any takes on what I do? Hey, done. It's an interface. Nobody cares. Like now, this is the bridge. This is the entry point to the clean inside, interfacing to the dirty outside. This is fine. Nice one, by the way. The only issue here is no, it's actually fine because we can change this as well. On the inside, we call it DB. There's another issue though. Once we get there, I will start doing small commits. By the way, sorry about that. Just to shave off some live coding minutes. And DB. Prisma is not modular because nobody codes this way. Everyone does the Ruby on Rails, 3-layer, everything is global, and we pretend we don't do stuff. Oh, thank you, sir. So it just explain. I can't put model challenge row inside of my folder and build a modular Prisma client just for the challenges module. But that's what I want. The reason why I want it is I don't just want to be able to take my code and move to a new microservice. I want to be able to migrate data to a new database. And nobody outside of the module is allowed to access anything past the public part of the module, especially including the database. A lot of y'all will use the database as a communication channel between different entities, and you will join, like left join, whatever, and have many relationship and just use some ORM that solves that for you. And then you try to create microservices based on your spaghetti architecture, because that's the definition, right? Spaghetti. It goes like everything just nests into each other. You created that by joining different tables from different entities. You didn't go through the service layer. You didn't go through the router layer. You just went through the database, the lowest layer. And then you create the coupling everywhere. And said, like, that's how you do it. I'm so proud. I did a many relationship using joins. Hooah! I'm a real programmer now. And yeah, congratulations. Spaghetti architecture. And this, I actually have, like, most of the stuff, yeah, it's my take on it. But seriously, if you learn about microservices, that's the number one rule. You need to separate, and no other service is allowed to touch another service's database schema, group of tables that belongs to it. So here's what we do. We create conventions. But yeah, that's the best thing we can do. The challenge row here, first of all, added row, you can add, I heard record, in some cases, row is shorter. It just say that this is a type that belongs to the database layer. And it's in the singular because I like that. We know that everything that starts with the prefix challenge belongs to the challenge module. So if I do another user, then I know that it would not belong to the same module. And if I need challenge score row, and I know that this belongs to the same module by convention. That's one of the things we can do. Another thing we can do, because yeah, just because you have the naming convention, it's still seductive. You have that damn product owner stressing out. It's just faster to do, like, just reach for the database and get it done, get it out into production. Like, yeah, and now it works. It's stable, no bugs. Carry on. I think that's actually fine to put it into production the first time using only the controller, just the first modular step we did, and just grab the data you want, show it on screen, get the conversation going. Like the first time you ship something to production, that's when the conversation starts. That's when you can start to plan. That's when you can start to figure out. If you just have like what do you do nowadays? Planning poker, weekly sessions where you figure everything out, and then you pretend like that will be true when you sit down at the computer. Yay. Okay, so if you just get it out into production and you show, like, is this what you want? And of course you will have here, no. And then you figure out what they actually want. Then it's pretty simple to just like use that entire global layer with the database. But then once you get that, like, sweet, yes, that is what we meant. and you don't move on because you want to refactor and improve internal quality before you move on. That's when you do this. Let's see here. Pick, I think it's 2 arguments in this order. No, it's the. Thank you. And here we see everything. And which one do we pick? So now I have access to challenge row. Sometimes, and you might need multiple picks. And especially not only the models you want, but sometimes you need a dollar transaction if you want to do transactions with your stats. Don't do transactions, not even in the early phase, because you can't split it up. So if you need to do transactions across modules, find another way. That's a delicate discussion, to say the least. So I will defer that. Okay. This would be a commit. And let's skip. I think that we're pretty much, actually, just let me wash up. Work in progress, skip to the end. You'll see that in the change log. Yeah, I think that that's the most valuable part here. So if you have this little fella here, we haven't really used it yet. What's the point? The only point here is that you can choose to use service on the outside any way you want. Then another point here, you can adapt to any kind of client interface things. So WebSocket, you can just create more factories. If you need all of them, you can have one factory that hooks everything up if you want to. But we'll see the value of it in final. Any questions so far, by the way? No. Okay. Hopefully you're following along somewhat. So let's see the final result. We have the almost same thing in the main, except things. I need to explain that. Process and sandbox. Oh, it's actually on. Okay, so I have an example file. Copy paste. It is git ignored, so it will not be committed. You can do any code you want. npm run that. If the database doesn't work, yeah. Thank you, Docker. It worked before we started. Anyhow, so you can write anything here. You see service get all. So what I do here, I create the Prisma client. I created the module. I grab the service from the module I want and get everything, do a bunch of transformations, log things out. I usually use this when I have specific cases and want like a lot of data, or want like stress test, something, create a lot of things, but just once and then carry on. Then you can do it here. Just run it as npm run dev, see that everything works, or like see the data, and then go do something with the AI UI, and then we're done. Turn it off. Now it works the normal way. Yeah. So that's a small little hack. That has nothing to do with modular monoliths. It's just a nice way. And this is the trick you just require. Because if the file is missing and you have a static import here, it will crash. So you need to do it dynamically. There's a reference, by the way. So github.com/Marcus Rådell/code typing. Then you can find everything in the final modular monolith. And we have the same tests as before. That's not interesting. Error handler. Here's the actual error handler that I ended up with. You check. Yeah, that is just temporary code. In the end, you'll basically check for SOD errors. SOD is a validation library for TypeScript. It's awesome. Please use. And we'll see that as well moving forward. But here you have the error request handler. And as I said, this works with promises in version 5. So it's really sweet. Still that same re-export. This looks familiar, right? And same thing here, it's just done for, so now when we have done it for all of them, we can kind of see like res JSON data. And when we get all, you don't actually have any input at all. But in the rest of the cases, you have kind of that sandwich. The input, which is effectful because it comes from the outside. Then you have the service layer, which in some cases it's usually effectful as well. But yeah, okay. In some cases, some people write it in a way where you have effects, then the pure stuff, and then effects. And usually it's kind of the same sandwich, but it's a bit recursive. We will have a bit of UUID generation and stuff inside of the service layer that's also effectful. And then we'll have another pure layer that we can unit test. And we'll get to that. But overall, if you squint, you should see a pattern with the data and REST JSON and see the opportunity here to create some kind of thing that you can just send in the service layer, and then you can just generate the entire router. Especially if you do REST, it's a bit trickier. But if you do a more explicit, instead of having slash, here you could have /get, and you could have no, that's get all. That style. So if you name all of them, then it's simpler to go take a look at the method name in the service layer and translate that into a routing layer that just does everything for you. And you never have to write another controller in your life. This is called thin controllers. Same thing. It's not about modular monoliths. You should have thin controllers. Even if you do the validation, then it should be part of the framework you're using, so you still have a thin controller. If you have more than the small sandwich of like grabbing the inputs from the request, doing the service layer stuff, and sending back the data, good luck finding someone that promotes that actual architecture. I don't think I've ever seen anyone say that's how you do it. Okay. End of rant for the router. Now comes the fun part. For the small amount of code we have, this is not necessary. Please don't do it if you write this little code just inline. So just to show how stupid this is, it's another level of indirection. But okay, before I show how stupid it is and then how smart it is, let me just say, so for me, the C in MVC stands for controller, like you all think of a controller. But for me, what a controller does is actually, it creates stuff and composes them. That's what it does. Just create stuff, connects them, then moves off. So for me, this is a controller. I heard compositional root. I heard that as a term recently. So compositional whatever. So this is a composer, you could say. Or if you like the word manager, it manages the resource, and we all love that word when we have variables, yada yada variable. Then you have service manager factory. That's awesome. Find a way to make it abstract. Then it's awesome. Okay, But the main thing is like that when we talk about your code should do one thing, I hate that rule because we never specify like, yeah, but what do you call one thing? It's like me walking here and have a live code session, that's one thing. Me taking a step forward, that's one thing. Doesn't even mean anything. So this is more specific. Your file here, if it creates and composes, it's not allowed to have logic. If it creates and composes, it's not allowed to have logic. If it creates and composes, it's not allowed to have logic. As I said, like a lot of the rules here are fractal. At some point, it goes too far, and it's like, okay, but there's so little logic. Like in this case, line 17. Where's the line? Where's the red line of what logic is? And sorry, that's, yeah. 5 years later, ask me again. We can have a long conversation about it. But it's quite a nice, like if you're a team lead trying to get your code cohesive and your team cohesive and work in the same direction, it's kind of nice to just like, yeah, that's a composer. Okay, then throw it out. You might have an extra layer of complexity and indirection, but at least it's coherent and you have good lines that were like good rules, good heuristics to follow that will scale. So I'm fine with this overhead actually. So let's look at how awful it is first. Get a folder with an index file. and now you have the DB thing with that abstraction of Prisma client, and yay, 1 line. We didn't gain anything. So you can inline that if you want to. You can do whatever you want to. There's no good payback here. So let's look at where it's actually worth something. Just know that even if it's not worth something, those cases where you kind of can practice and reason about it. It's simpler. There are less things to have in your head. So playing around just because it's like worthless from a code quality perspective, it's really good to start practicing just the mechanics of it. And then when it becomes important to use, you know the basics. Let's look at create. By the way, when you go back to your code base, look at the file structure. Look at the questions that you can get answered without looking at the actual content of the files. Guess how hard it has been for my teams, multiple teams, to not have any conflicts, to not understand anything about what anything does in the code base and still improve or update the code with new requirements without any overview of the code at all. It's pretty simple, especially when you standardize it even more. They just see the URL in the client. Like you have a front-end programmer needing to do some back-end stuff. Then you see the URL, like, okay, I can guess the folder right now. I haven't even opened the back-end project. That's what we did at Svea Solar. We had a bunch of mid-junior front-enders contributing to the back-end in a modular structure at the same time. No communication between the front-end teams. No issues. Did great. Still had that last commit from the senior back-end guy, though. Yeah. Okay, so let's zoom out. That's not zoom out. That's zoom out. Index file now. You see it has most of the code here. I will show the validation stuff just from the outside. Raw input, stole it from TRPC, that convention, that just to mark that raw means it's not validated yet. We know the type if you use it through the sandbox or some other type safe way. But if it's through the network something, we need to validate or parse it. And now we can trust it. Now after the validation parsing stuff generates, and this is effectful input output. Just call it IO, to be honest, to get away from the pure function, effectful function discussion. We have another input that's non-deterministic. But then I had a hard time finding the word for this layer. Like, what hell do you call the logic layer? I started to ask people, like, hey, the logic layer, like, what should I call it? Like, the logic? Oh, yeah. Might be a bit unconventional, but again, like, anytime people talk about that layer, they say like business logic or something. So yeah, just makes sense. It's the pure layer. If it's the front end, this is the reducers. In the back end, if you do event sourcing, you actually have a reducer function, but just calling it logic makes it pretty clear. Okay, so we send in all the inputs that were effectful into the logic. We get data back, and then we give it to the database and return to the client. So that's the sandwich again, right? Input stuff, create the effectful inputs, then you get the output from the logic layer, and then you give it to the database and the clients. Yeah.
At the input stage in the big factory, we have raw input, which is then parsed in order to like modify it and transform the data. Then we pass the data into the create function. Where would you say that we would have to parse the data for sending it? Like, should it be in the create layer, or should you validate your output?
Let me go.
Below, so
I need that rephrased, or.
So you've taken input.
Yeah. So we have the raw input.
And you've parsed it.
Yeah.
Sure that it conforms.
Yeah. And if it doesn't, it just.
You have the logic layer.
Yeah.
But you're not. Where would you make sure that data now conforms to create? So TypeScript. I mean, logic is just okay. Yeah. I'm okay. So let's. Okay. So the question is, line 13, data. How do we know that it conforms? So let's do data. Let's. If I put any, okay. Anyhow, if we're missing something, let's see, logic, we remove level. You already see that it's red. So the return type of logic needs to conform to what the database needs. That's otherwise you will get a type error. Is that an answer? No. I'm more like since we have a parser to parse that, parse the input to make sure that it's conforming. So and it probably goes back to the whole thing about be liberal with what you take in, but careful with what you return. I guess. So
that's a crappy rule.
That's whatever you get in, right?
No, yeah.
So, then when you call create, that's on the Prisma layer.
Yeah, that's the Prisma layer, exactly.
And the Prisma layer itself will then will that have some sort of like validation that the input that you're providing?
Okay. In a few ways. So the Prisma client itself will be typed using TypeScript, but then you can lie. Let's say we didn't have level as any, something like that.
Yeah.
So we're lying our asses off, and that's a bad problem. Oh, now I jumped.
Suggest another case that you have a table with you can have 50 characters in this column, but you're sending something like 1,000 characters, and then it will throw an error.
Okay, so If you want to validate that in some kind of way, then yeah, you would need some kind of pre-layer before the database. Then, and how do you make sure that that conforms to the actual rules? Like it needs to stay in sync. So there's an in sync problem here. In this case, since it's your database, I would just say if it is an issue, you basically need another validation layer after the logic.
I'm more asking, like, what would your suggestion be in that case? Like, would you want to have another parser between?
Yeah.
Or would you like assume that?
The problem though is like if as soon as I do that, just make sure that you have a single source of truth. Like the bad thing is if you want to validate the data before you send it to the database, have one validation layer that actually works. The problem is if you validate on 15 here, like validate or parse data to conform to DB. If you change the constraints of the column in your database, that you need to automate that parsing also updates in the same way, which is really hard. So maybe then don't restrict the database too much if you can have it a bit flexible and make sure that the validation parser is a bit stricter always. So that's a good way to say it depends. It's a sucky situation to be in. In those cases, I would be pragmatic. And if a runtime error is enough, so you can trust the database. In the case that we got suggested here, that you have like, it's too long. Let the database handle that then. And if you can have, and then you have the validation layer closer to the database, and if you move that somehow in some exotic architecture, it will move with it. So it's a poor answer, but the main thing I go with is not so much which line where do you put the code, but how do you keep that validation parsing in sync with the demands of the database. That gets to decide. And then if it's like after the logic layer, or in like you make a repository layer, does that's more on the implementation detail of like what your team needs. And you can try different alternatives in different modules, as I said, if you want to experiment with it. Nothing in a specific architecture that I know about will go into those kind of details. It's just so depending on the ORM or the language that you use. But hopefully most of the constraints you can actually use in your ORM or database. Otherwise, I would probably do a repository layer to try to keep it in sync.
But don't you have that already? So you try to create a row, it fails and it throws a validation error. It fails because so too long, whatever.
Good catch. First of all, what happens if we have a connection error? I shouldn't expose myself too much, but wait, yeah, you brought it up, so damn, you got me. This is not really a validation error. I had another workshop, and this is so behind the background. This makes sure that we try to make sure that you don't insert the same ID twice. I think there's a test around that, or name. If you have a challenge with the same name, you try to insert it twice, that will break unique constraints, and that will create a validation error, and that was the point we made in another workshop. So in this case, it's actually not only validation error, but that's an example, like unique constraint on the name. So that's true. Then we actually have it in the database schema unique constraint. And that will follow the database then. So then, as long as you can stay here, that's good. In some cases, you won't be able to. And then we need to start being pragmatic, like write not perfect code. That's fine. if you need to. The more exotic constraints you have, just know that then you just in the modular monolith architecture, you can say like we have a really specific need for this module. We can have a repository layer in this one. That adds another layer of abstraction. And that's not fun, but only in that module. So you can reduce the cost for those a bit more exotic needs. Good enough? Yeah, good. Yeah, we can talk afterwards. But I think that was a fair question. Okay, logic layer. We'll jump into it. Got all the inputs we need, and oh yeah, roll it back. And this is just a quick example we came up with. Sorry about it, of course. Yeah, okay, so the idea is that programmers doing programming tests on a Monday, you deserve a bit more score for good work. So it's just to show, now we can actually unit test that on the Mondays we get the expected results. This actually crashed when we did a dry run on the other architecture session because we actually did the dry run on a Monday. I was like, what's going on? It worked yesterday. Yeah, so we actually have unit tests for all of the behavior. And that's super nice. And as I said, like until once I spent like a couple of minutes on Docker just to reset everything, then the actual unit tests will work. That's it. Oh, I'll buy your beer afterward. A free beer. Oh, if it doesn't work now. It's gonna record it. Hey. Redemption. No, but that's all. Needs to see this. We'll hire you. Yeah. Okay, so that's a lot, and then input here. I mentioned TypeScript as a framework because that uses SOD and it has that validation layer, that framework. Even then, when you inline it into the controller layer, you can actually extract the definition on the outside. You could even, in such a framework, because I extracted it, say, I'm not going to add the validation to the visual controller. I'm going to put it in my service layer. There's a little bit of like boilerplate. What I've done is that we actually use gRPC at VPTech. They're hiring. And each and every endpoint that we have does not only in gRPC, it gives the client, it gives the types. You get type safety automatically. We have that for our errors, specifically for we don't have it everywhere. We have it in some module, but we actually have type safe errors by returning, like controlling the schema the right way. We can do a bunch of like cooler stuff and get even more type safety than what the offers from the box. I hope that Alex, the author, doesn't see this because then he'll call me up and yell at me. We get a tiny bit more type safety. Okay. So it's quite powerful, and you can do this even if your controlling layer wants the validation. You can extract it. You can put it in the logic layer if you want to, and then you can even improve it further to reduce the boilerplate again. Gain control. And that's about it. And one thing. It's really nice with the folders and that thing where you can get that good overview. If you introduce it to a new team, they weren't here, they didn't like buy into it as much as you do. Stop before you break it out to the subfolders, because people will get a bit annoyed like with the level of interactions. So just get used to the modular thing. Start with the controller, like that's high value right there. And before you actually want to have unit tests, and this can be inlined, yeah, this is not as valuable. But again, depending on the team, if you want to have a full stack team that can move across the stack, you don't have time to understand everything. You want them to be able to contribute quickly, like the front end expert needs to be able to create some dummy data on the back end and do something. It's like, oh, you need to create something, check this folder, this is what you need to do. Like this is a recipe of the steps that you need to go through and program. Copy paste, go through those files. They even know, like, you know how hard it is for me as a team lead to go through and make sure that they wrote the right tests. It sucks to go through this modularity where you can like check, does the create function have all the tests it needs? It doesn't suck as much. It sucks less. Use this time. It sucks less. There's still a lot of scrolling. Like I want to have the whole all of it in one screen if I can. But this is good enough. Yeah, do this. It sucks less. Thank you. That's all. It's actually that's all. You can
If you roll back the module you want, but is it like you decide the policy you have to execute different?
So can you take that again?
You said something, we shouldn't, when you write service, we shouldn't extend my service, it should be from TypeScript, right? Somebody mentioned that. Code, you should be from TypeScript, not from other.
On the service layer, you shouldn't depend on outside types. Yeah, and that's a three-layered architecture is usually defining that. So the definition of if you don't do modular code, so you just have global layers. I will always try to emphasize global layers. So because people go like, that's not that global. You're like, yeah, it's global. You're doing global stuff where everything in the top layer can access and anything from the bottom layer. But then usually the service layer is not allowed to use an outside interface. So if you think about Java, C#, classical languages, you're not allowed to use that interfaces from a third-party library inside of your service layer module, in my case, except for me, then I have the anti-corruption layer is one term in DDD, I think. You need some kind of like adapting layer between the dirty outside and the clean and controlled inside. I do it in the index file for the module, but others could just say you're not even allowed. So the classical way, then you would not, and here I moved it to types, by the way, just so you know, but you would not be allowed to even do the proxy thing here. That would not be allowed in a classical architecture. So this is me being pragmatic. They would actually need to type out everything manually. In that case, that's where people start to do like repository patterns, so they can reduce the amount of like types they need to define. TypeScript is structurally typed. The classical languages are nominally typed, meaning for us, if you have two different types with the same shape, they're like substitutable. So in TypeScript, that makes this okay, because nobody knows, like if you switch the right-hand side of a type and it has the same shape, nobody will know that uses your type. So you're doing type aliasing as we did before the pick stuff, where we had. So doing this kind of aliasing in TypeScript, that's fine. It works in other languages that are more classical. Then you would probably need to define an interface. You would probably then need to use a repository and do a bit of extra work. So yeah, but it is the defined characteristic of 3-layer architecture if you want to like study that more. So that is not actually something that I made up. Any other questions? Yes.
So today I was working with a use case that after I had, when you create an account on a web page, after that I want to schedule a notification email, the welcome email. Mm-hmm. So if you look at the challenges, create the index. Yeah, then in that file I want to like, after I have created something in a database, and I'm sure it is in my database, I want to have some post logic of things to do after that. How would you structure that, or is that like bad structure?
You need to send the email, right?
Yeah.
So,
to send an email.
Okay, schedule. Can we bypass the schedule? Oh, it doesn't matter that much. Just trying to.
I have a notification service, which is another service.
So basically, you need to talk to another service.
Yeah, after it is created.
After, so.
But then I have to unschedule it if the validation error happens in line 20. So.
Okay. So let the database is done now, and then we schedule emailer scheduling service. That's a terrible name.
That's like notification service.
Oh, okay, yeah, thanks. Notification service. Schedule email.
Yeah.
Data. Yeah, something like that. That's pretty good. And then, okay, so there's a maturity ladder here. So let's just start with the simplest step before the naive approach, which usually works. So we have a dependency on another service. We don't have the dependency on another service's database. And when I say service, that's just like the main, not like everything works as it's supposed to. You have the validation, you have the pure logic, you have the database saving. All that together is the service layer. If you nerd down, you will see transaction script and use cases instead of service. But those are so internal to like the original Agile manifest people. So it's like people don't use those terms anymore. So module is basically just a creation layer where you get the service back and then the ability to create then routers and different kind of things. The main meat is the service layer. So this is another then module that we created, and we injected the notification service into this here. Notification service, forgive me, Father. Okay, we're not focusing on types. And then, of course, I have a shitload of index files. So create. Factory. So just send it through. And what do we call that? Prop drilling in React. It's a good thing. We can have that discussion later on. Prop drilling, make it a positive word, please. If you do this because Marcus told you, and then I see like you replace this with CTX. Do not say that you did what I told you to do. I do not ever want to see a CTX where you put all your global dependencies. we have the exact dependencies we need here. So, and this is a really good characteristic. So let's say we bubble it up. So here in our compositional root, the top level composer, we then have, do you use like do anyone use a DI manager? No hands? Depends injection manager? Hooray. Nice. Oh, it's Express people here. We don't have like Java and C#. Like, of course. Okay, so we don't have to have the discussion of how the issues of those. So now then we create the notification service that we pretend exists. Module. Module. That gets sent in here, except, so we don't send the entire module because we don't need to create the router inside it. We just need it here. We don't send in the service because that's not what we need. We need the ability to schedule email. That's what we send in. We send in what we need. Yeah. Now your code starts to talk with your programmers. This is very exact. And another thing, wait, we want to schedule the email, but this is a notification service. So some of them want also have in-app notification. And some might need a native notification or whatever. And it's like, that CTX looks pretty nice right now. Or it's like, can't we just like send in the service? Come on, be pragmatic. No, because then you make it simple to create the code and write the code, but you actually hide your dependencies. If you start to pile up all the different services you need and all the dependencies, and then you just put stuff on CTX or you just send in entire services and you use 8 out of 10 methods, nobody knows from the outside. This is your overview. This is your dependency graph. This is what shows you, like, we got ugly code. Where it really matters, like spaghetti code, how scalable it is, how modular you actually are. Here's the everyone's reads. Okay, so this is where you can actually see our code sucks on line 20. Our code, for example, most of you will have some kind of identity, like some user thing where you send, like you create an account, you send back the JVT, and then you have an ID for that created user. Almost all the other modules will depend on your identity service, or your account service, whatever you call it. Don't call it user service because then you just grow and grow and grow. And then we had the comment about we don't want cyclical dependencies. Do it this way, you will actually run into trouble when you try to have cyclical dependencies. And having the dependency on that, every other service module or service depends on the identity service module. That means that the identity service shouldn't depend on something else, because then you get into a cyclical dependency issue, right? And that's something I saw in my last assignment. We saw like, oh shit, this is a constraint in our system now. We have this core service that everyone else depends on. We want to be able to like get the user by email, like invite the user by email, and you want to invite the actually ID, right? Because then you can change their email later on. So then you actually need to replace the email with ID, and then you might actually need to check another service. Then this will give you that map of those dependencies. Have I missed the target on the question though? Yes, I kind of have. That's another, yeah, exactly. That's what we missed here. But at least
for me, it's like, is it okay to put it afterwards, or should I extract it?
It is post logic now.
Yeah,
you have, yeah. So you have the database, but okay, yeah. So rolling back, and basically we can call it eventual consistency. And now we're talking distributed systems. Welcome to my second live talk for the evening. It's a 1-week course. You can sign up at Salt, but the short version is now when you have two asynchronous like code network and you need to kind of have them in sync, you want eventual consistency. If you put it in the database, you want to make sure you don't drop any notifications, right? Would that, how terrible would that be if you actually didn't send out that scheduled email? Would it be really terrible?
No.
Yeah.
I would like to know how often it happens.
Sure. Okay.
Yeah. So in my case, I would probably like, if this line 24 fails, please like send it to Sandry, to bug report, or like log in somewhere that this actually failed. So
it depends on, yeah, but if it crashed, like hard crashes, like out of memory crash or something, might even get to the cache. So nothing you do there. It's like, if we really talk about serious stuff like data engineering, software engineering now, eventual consistency in a distributed system, you need to sync those. I think you could do, you need to choose if you want to be able to, like, you want a 0 to 1 promise on, you might send a scheduled email 0 or 1 times, then you can achieve that basically by this kind of code. If you want at least once guarantees, then you need to realize that it might send it more than once. And if it's an email, maybe that becomes an issue then, that you have a logic bug somewhere, and some plastic for some reason retrying. But usually we want at least once guarantees, and then on the notification service, you can dedupe. You can have a window of 5 minutes or something where you save the transaction IDs or something. So if you retry, you can find the transaction ID and say it's already sent, fine. And then if it retries later than 5 minutes, it's gone from that cache. And complex, there's some tricks you can do with since, yeah, that's actually, okay, so the best one in general would be to then have challenge outgoing row. No, not something that's like anything you want to have outgoing, and you want at least guarantee. Then you add a table for that. You have it in a transaction. You can have a transaction as long as it's in our set of tables that belongs to us. Depending if you use like MongoDB or so it depends. But this is, you can actually do a similar thing with another like send false and then set it to true if you use Mongo. But the main idea here is just like you put the stuff in your own database, and then using the transaction, also say like you want to insert something on the transaction table. You send off the notification, and now you delete it from that queue. Okay, so that means if it crashes after you send the notification, you didn't delete it from the table. So once you restart, you go through and you see, and then you need some code here that when you create the module, it always checks the queue and sends anything that's left on the queue. Then you have multiple services, and stop here. Distributed systems are fun. Yeah.
It's modular monolith.
I usually do it though in a way where you should be able to run it in multiple services. So even if it's like monoliths, you can use serverless, you can do those kinds of things to a certain scale. And then we have issues with it being too slow to start up, or like you have a specific module that's heavy. That's when you actually modularize the app part and put it on npm as a private package. Then you can just take the module folder, npm install module core, and then hook it up. So actually, it should be fine to use in the distributed system kind of way. It's just like I can recommend .io, Keith Rickerson, I think. Sam Newman also has great content. He will also push for the whole database schema isolation part. But it is like, that's one of the trickier parts. So I would just have, before you solve that distributed at least once guarantee problem, just realize that most of these like huge systems, then you have a discussion. It's fine if you drop this. And if you ever think about like, you want to have a ticket to a huge show, they need to be able to handle a huge spike in traffic where everyone wants to book the tickets at the same time. Or same thing like Amazon or whatever, you want to buy a teddy bear that's like the gift of the year or whatever. They need to make the decision of, do you allow someone to reserve the same teddy bear or the same ticket at the same time? Or do you reserve it while they're in progress, and then you might actually lose that sale because someone reserves it and don't buy? There's, even when you have the computer system have that guarantee, you still have the same issues in the real world. When interacting, it's a UX problem. And this will always be a UX problem, and as long as you're fine with it, once in a real, like there's a tiny chance that this will actually crash. And then if you have a worker, some kind of worker, some kind of job which monitors how often you have the problem, then you're fine. If you actually have the problem, then you can look at these guarantees. Because it's worse in this case, I would say, that if you spam too many emails, then you're really in trouble, because then you can get blacklisted. Yeah, cool. Good question. Great questions.
I thought the same. But I change some rows, but you can block them.
Yeah.
Like you mentioned before, namespace. So you can identify them. And I thought, you say, I could have namespace. Doesn't have to be handled here.
Even yeah, okay. So with the payments, yeah, learn from Stripe if you want to like use some kind of API where you can practice these things, and that's where I think that most programmers need to learn about authorization and authentication, and also like using a payment service, just because that teaches you how to handle transactions with retries and how to use some kind of transaction ID or whatever. Idempotency is a really good thing to reason about when you communicate with other services. So yeah, payment services really
They have this problem. They come, now they start to get spamming. You know, they didn't have it before. Then they come up with this namespace, which is
the main thing is that you can somehow deduplicate requests. Okay. Another one thing that is said about like using Kubernetes or serverless.
That's
yeah. And the main thing is that even if you
it was go back, like you mentioned now, we cannot. Somehow you want to create a rising mesh. Are you right R providing just to pick what column not every just as exactly not like it's complex.
Yeah, I think that's an offline discussion, especially when you go into R and data lakes, because then because a lot of things that I say in my like a whoosh on you, it's whoosh on me. The main thing for me is like just realize that if you do it in some kind of like cloud, because I do this using GCP Cloud Run, and if you use Kubernetes or serverless in some kind of way, if it crashes and some other takes over, then you still have the same issues as if you had one that restarts. So it will not help you that much. It will help with like the load of the request, but not help a single request. Yeah. But okay, so it's about 2-hour mark. So yeah. Okay. So I think great questions. We will have more discussions for those that want to hang around. Those are online. Thank you so much for joining. If you have any questions, ask the audience solve all of my problems for me. I'm so glad. This is the screenshot. This is the thumbnail screenshot. Passing tests. It ran once. Okay, I just need to run. No! Okay. Yeah, thank you. Yeah. Stumble on the way out. Thank you.